Alright, so today is going to be trig with any angle. So our idea is we want to find trig functions from any angle that I've been given. And the first thing to look at is everything we've done so far has been with a right triangle, like so. And so with our right triangle, like we labeled some of these sides, right? We said, all right, this side was maybe like a 5, and this side was 12, and this side was 13. And let's say our theta was right here. If I go from here, I can find any trig function that I want, just based on that triangle. So I've got sine of theta. Once I have my triangle built, I can find the trig function of whichever angle, wherever they want to put the angle. Okay. So for sine, we would do what 5 over 13. Cosine, we would do what 12 over 13, so on and so forth. You guys okay with that? That's not too bad. Now, what happens if our theta is predetermined for us, and we have to graph that on some kind of circle, kind of like that worksheet we've been working on, the 13 two-sided with pi over 4s or graphing certain angles. I want to find trig functions based on those angles if I can. The nice part is we've done some of this stuff before, but let's say I want to find the 6 trig functions. Let's say my point now is going to be, I got it written down right here, sorry. Negative 12 and then negative 5. Okay, so let's say I'm given the point negative 12, negative 5, and I want to find the 6 trig functions for this point right here. Well, the first thing you can do is graph it. Okay, so if I were to graph this point right here, let's just go ahead and graph that. My main goal is to build a triangle, and we all want to try to build the exact same triangle. If we can build the exact same triangle, hopefully we'll be good to go. Okay, so if I graph negative 12, negative 5, that would be negative 12 would be way out here, negative 5 would be down here somewhere. Okay, so that's going to be about the point negative 12, negative 5. Now, if I go from the center of this graph right here out to that point, kind of like radius, like that, what I want to do is I want to build a triangle based around this line right here. Now, just so everybody has the exact same triangle, what we do is we go from this point, we go perpendicular to the x-axis. So we're going to go straight up right here and go perpendicular to the x-axis. Now, the benefit of doing that is if I do that particular triangle, I can label all the sides, right? I know how big this side is, right? How big is this side right here? 12, okay, so I'm just going to put a 12 right there. How big is this side right here? 5, okay, and how big is this other side right here? 13, okay, it's the same triangle as before. Now, our theta that we're talking about an angle from the inside right there. That angle they're called the reference angle. I'll explain that in a little bit. For now, I'm just going to put a theta in there, and we're going to take a look at that. Okay, so if I want to find the trig functions of that triangle, I should be able to find it. Okay, so for example, if I want to do the sine again, the sine of my theta, sine is going to be opposite over hypotenuse, so this is going to be 5 over 13. Cosine, let's do cosine. Adjacent over hypotenuse, so it's going to be 12 over 13. And the last part there is going to be the tangent for this one, and I'm assuming you guys can find the other ones. This one will be 5 over 12. Okay, I'm assuming you can find the other 3 as we work on this. Now, we have a slight problem with what I've done here, with all of these actually being positive. Notice on the sides right here, I did 12, I did 5, and I did 13, because it seems kind of weird for our brains to think about a negative side on a triangle. However, I technically went a negative 12 right here. And I technically went a negative 5. I went to the left, which is a negative direction, right? I went down, which is negative direction. And this 13 is a radius, and the radius is never going to be negative. If we did Pythagorean theorem, that number would always end up being positive no matter what, okay? But as I look at this, I actually have 2 negative numbers right there. So that's going to change my values over here for what that's going to be. First off, the sine right here, sine was 5 over 13. Should this be positive or negative? What do you guys think? Should be negative. The 5 should be negative, and the 13 is positive on this one. So that's going to be a negative value. Okay, so the sine of that theta is going to equal negative 5 over 13. Okay, now cosine is going to be either positive or negative. Negative on this one. Okay, so negative. And then the tangent, what's the tangent going to be? Positive, because it's going to be a negative over a negative. Okay. Now the way to help you remember that, there's actually a little trick for that. It looks like this. And it's ASTC, and there's a bunch of different ways to remember this. So there's all students take calculus, this is the Math Geeks version of it. There's cast away, so if you start at the bottom right, and then you go cast away like so. The weird part is that starts in the wrong spot. But anyways, what this is, this actually tells you which trig functions are positive depending on which quadrant we're in. Okay, so if I'm talking about this right here, A actually stands for all the trig functions. If I'm in the first quadrant, all of the trig functions are positive. Everything that we've done so far, as far as like the previous triangles, those have all been in the first quadrant. If I were to draw the first quadrant like that, right, they're all in the first quadrant. So that's why all of those were positive. Okay, so that stands for all of them. If I'm in this quadrant right here, that means that the sine function is positive. Okay, so if I'm up here, the sine's positive and the rest are negative. If I'm down here in the t stands for the tangent. So that means the tangent is positive and the others are negative. And then over here, c stands for the cosine, so that's actually the cosine. cosine is positive, and then the rest are negative. Okay, so depending on which quadrant we're in is going to tell us which one is positive or negative, depending on where we're at. Okay, does that kind of make sense a little bit? Now, the reason I do this ASTC right here is because for me, it's weird to have those being negative right there. I don't like putting those as negative. Because technically they're sides on a triangle, they should all be positive, okay? But once I land in a certain quadrant, that's going to tell me which trig function is going to be the positive and which one's the negative, okay? All right, cool. So that's kind of the basic beginners of it, okay? So let's do one more real quick, just to make sure we're feeling okay on that. Let's say my point now is going to be at 5 and then negative 2. Okay, so we got the 5, negative 2. I want to find the trig functions for this. We're only going to find the first 3, sine, cosine, and tangent, and then we'll go from there. Okay, we'll find the other ones in a little bit. All right, cool. So first thing you want to do is graph this point and try to build a triangle based around it. Today is all about building the right triangle, building the appropriate triangle. Right triangle, very funny. And then hopefully labeling the sides and be good from there. Okay, so let's go ahead and label all triangle. So if I go 5, negative 2, that means I go out 5, and I go down 2. Now, it doesn't really matter exactly like how accurate your graph is, because all you're really worried about is which quadrant you're in. That'll tell you the sign, positive or negative, and then labeling the sides correctly. Now, our radius is going to go from here to here. Pretend that was a better straight line. Try that again. Right there. And then I'm going to build my triangle. I always build the triangle to the x-axis. So I'm always going to go straight up right there. It's always going to be perpendicular to the x-axis. If we went over here, everybody's going to get different answers. So just depending on which triangle you build. So if we always go straight up, we're all going to get the same answers. Okay. So on this one, I should be able to label the sides in this triangle. This side I went out 5. So I know this guy right here is 5. I went down 2. So I know this one's 2. And now I just want to find out what the hypotenuse is. Just do Pythagorean theorem real quick. So we're going to get the square root of 29, right? Radical 29. So that's going to be the hypotenuse there. Okay? So now I can find the 3 main trig functions. You can find the other ones. You just flip them over, right? You guys are good there? So let's do the sine of our angle, sine of our theta, which is going to be this angle that they're talking about right there. So sine of theta equals, the sine is opposite over hypotenuse. This would be 2 over the square root of 29. Which we'd have to fix, right? We don't like having that squared in the denominator. So this way, if you multiply top and bottom by square root of 29, it would give you 2 square root of 29 divided by 29. Okay, so that would be the sine function for that one. Yep.
If the fraction, if you can, what's it called, reduce it?
Yeah.
Can you, or do you
Sure.
leave it?
Yeah, you can.
Okay.
Yeah. You mean like if the radical is reducible? Like if it was square root of 40 or something like that?
After you multiply it and it's like 2 over 29, you can reduce it for these kind of equations.
I'm a little confused, because this one you can't reduce. Are you talking about if it was 2 over, let's say it was square root of 30?
Yes.
Can you reduce the 2 and the 30?
After you have put the radical on top and it's 2 to the radical 30 over 30, you can reduce that.
Yes.
Okay.
Yes, and that's okay. Yeah, I'm with you now. Okay, I thought you were asking if you could take like the 2 and 29 and try to reduce this. I'm like, watch out for that one. Okay. Yeah, what's up?
Oh, would it be negative 2?
Yeah, I haven't got to the signs yet. What I like to do is I like to do all of them and then come back at the end and just fill in the signs. That's usually what I like to do. Okay. So then I do cosine of theta. Cosine is going to be, let's see, adjacent over hypotenuse. This is going to be a 5 over square root of 29. Which, if I rationalize that, that's going to be 5 root 29 divided by 29. And then the tangent of theta. Tangent of theta is going to be opposite over adjacent, so this will be 2 over 5, which I can't really reduce that. Okay? So that's what the 3 trig functions are going to be, the 3 main ones. Okay, now what I want to do is I want to figure out which one's positive and which one's negative where. So then I fall back on that little ASTC thing, and that tells me which trig functions are positive where. Okay, so now I'm down here in the cosine quadrant. That tells me that the cosine right here is positive, and the other 2 are negative. So I know that this sine has to be negative, and I know this tangent has to be negative right here. Okay, so I know those are both negative. Cosine is positive because I'm in the cosine quadrant. Okay? Okay, we're feeling pretty good? Not too bad? I hope. Okay, so the only basic new thing here so far is the sign change, whether or not it's positive or negative. That's the big thing for right now. Okay? All right, let's go ahead and go a little harder, because now we're going to do something without our calculator. Okay? Let's go ahead and talk about the sine of, let's do a hard one, 60 degrees. Okay, now what I want to try to do is build a triangle wrapped around 60 degrees. Now, before what we did in the past is we built a 30, 60, 90, and then we tried to just solve that one triangle. Okay, now what we're going to do is we're going to put that triangle onto a graph. Okay, we're going to put that onto this normal graph that we've been doing, okay? Just a regular coordinate plane. So 60 degrees, if I were to graph 60 degrees would be going somewhere up like that. And then I'm going to build a triangle to that, okay? So if I build my triangle, I always go straight down to the x-axis or straight up to the x-axis. I know that my angle on the inside here is 60 degrees. I should be able to build the sides on that triangle, I hope, based on those shortcuts that we did, right? 3690 is the 1, 2, square root of 3. 1's the short one, 2's the big one, and square root of 3 is the middle guy. Okay, so now if I want to find the sine of 60, I can just go from the 60-degree angle right here and then find the sine of it. Okay, now the sine is opposite over hypotenuse, so this would equal the square root of 3 divided by 2. Okay, you can check your answer on your calculator, obviously, even though these are without a calculator. But sine of 60 is 0.866, right? And then square root of 3, divide that by 2, the same thing. Okay, so I'm feeling pretty good about what we've done so far. Okay, so nothing really there is that new. Now, should this be positive or negative? Which quadrant am I in? A, which means all of them are positive, right? So that has to be positive, okay? Now what happens if being in that first quadrant is pretty limited? What if I jump into a different quadrant, okay? What if, let's say, I want to find the sine of, let's go 300. Okay, so I want to find the sine of 300 degrees. That's my goal. And this is without a calculator, okay? All of a sudden they got 300. It's not a 3690 or a 4590. At least it doesn't look like it, right, at first. So let's go ahead and graph this and see where this is going to land us, okay? So if I'm talking about the 300 degrees, let's go ahead and graph that. 300 degrees, which quadrant does that land me in?
C.
The C or the fourth quadrant, okay? Either of those are fine, okay? So I land in the C quadrant, and if I graph 300 degrees, that puts me right about here. I don't know, it might be something like there. Doesn't have to be perfect. If you get in the right quadrant, you're going to be okay. Okay. Now we're going to build our triangle to that. Triangle is right here. We're going to go straight up to the x-axis. Now if it's 300 all the way around here, how much is left over on the inside right here? 60. Ooh, now it's a triangle that we do know. Okay. This angle on the inside right here, they call your reference angle. Oops. Spell it right. Okay, and most common for reference angle, they're going to use the alpha for your reference angle. Most common. Okay, your theta is your entire angle, how you get there. The alpha is going to be your reference angle. So my reference angle for this is actually going to be alpha, which is 60 degrees. So if I want to find the sine of 300, that's going to be the same as finding the sine of 60 degrees. Okay, my reference angle is 60 degrees. Now the only tweak here is which quadrant you're in and whether or not it's going to be positive or negative. Okay, now if I'm down in this quadrant, am I going to have a positive answer or a negative answer for the sine? It's going to be negative because I'm in the cosine quadrant. So sine of 300 equals the sine of 60. We just have to make that guy negative. Okay, so we're going to find the sine of 60, make our answer negative, we're going to be good to go. Okay, so we got to build this triangle just like we did any other 3690. Right? This would be a 1, a 2, a square root of 3. And I want to find the sine function for this one. Sine is opposite over hypotenuse. Opposite is square root of 3. Hypotenuse is 2. So this right here is going to equal the square root of 3 divided by 2. Okay? Now I just think about which quadrant I'm in once again. Think about if it's positive or negative. And so I should get, I'm in the cosine quadrant. If I do that little ASTC thing, I'm in the cosine quadrant. So this would have to be a negative square root of 3 over 2. So that'd be your answer that you're looking for, a negative square root of 3 over 2. You can check your answer on your calculator. If I do the sine of 300, I should get the exact same square root of 3 over 2 number. I got the, I corresponded that up there. Sorry. Sine of 60 was 0.866, which was square root of 3 over 2. And then sine of 300 is just the exact same thing, just happens to be negative. Okay? So we're just basically changing the sign depending on which quadrant you're going to land in. Okay? Does that kind of make sense so far? I hope. So if they say without a calculator, you're still trying to get to a 3690 or a 4590 if you can. Okay? So let's go ahead and do the tangent. Let's do the tangent of 120 degrees. See if we can't figure out what that one is. And this is without a calculator. At least that's the goal. The first thing that is good to find is find out what your reference angle is. Okay? Build your triangle and figure out what your reference angle is going to be. That's the angle inside the triangle next to the origin. Theta is how you get there. Alpha is the little angle on the inside. I'm picking on that number a little too much, huh? Okay. So that's 60 degrees. So if I build my triangle from this, right, I got 60 degrees here. Build the triangle. This side would be 1, 2, square root of 3. And now I can just find the tangent of that guy. Okay, so I'm going to do the tangent of, instead of taking the tangent of 120, I actually want to find the tangent of my reference angle, which is 60 degrees. I'm going to use that 60 degree triangle, and then I just figure out if it's positive or negative. Okay, and if I'm in this quadrant, is tangent going to be positive or negative here?
Negative.
It's going to be negative because this is the sine quadrant, ASTC. And so I'm in the sine quadrant, which means sine's positive, the others are negative. Okay, so that means I'm tangent of 120 equals the tangent of negative tangent of 60. And so if I do tangent, tangent is square root of 3 over 1, right? Square root of 3 over 1. And we're just going to make that guy negative because of which quadrant it's in. Okay, so my answer here should be a negative square root of 3. Check my answer on my calculator just real quick. I do the tangent of 120, and I get negative 1.73, which is the square root of 3 if I just check that. So it's the exact same thing, just happens to be negative. Okay? Feeling pretty good about this?
Yeah.
It's not too bad, I hope.
Very good.
Okay, good. All right, one more real quick of this, and then I'm going to show you the hard ones. The super hard ones. The ones that kind of make you use your circle, except for I'm going to cheat. Let's do, I don't want to do that one. I want to do this one. Let's do cosine of 225. Well, I can do that. Easy. Fuck. I'll just mark you wrong. No, sorry. What's our reference angle here?
45.
Our theta is 225. Our reference angle is 45 degrees, right? Okay, so cosine of 225 should equal the cosine of 45, and then we'll just think about if it's positive or negative. Hopefully. So if I were to graph this, let's see, 225 puts me down here. There's my terminal side, right? That's where it stops. And then I build my triangle up to the x-axis, perpendicular. It's 180 to here, and I went 45 past, right? So this is going to be a 45-degree angle on the inside right here. Which means I can label the sides now. It's a 45, 45, 90, which means this is 1, 1 square root 2. Okay, that's the other special right triangle that we were working on. Okay. And then now we just got to figure out the cosine. Cosine for this guy, cosine is going to equal adjacent over hypotenuse, which is going to be a 1 over square root of 2. And then I just think if it's positive or negative. Down here I'm in the tangent quadrant, right, ASTC. So if I'm in the tangent quadrant, that makes this a negative cosine of 45. And that just makes my answer a negative 1 over square root of 2. Okay? Don't like to have the square in the bottom, so just quickly rationalize that. It'd be a negative square root of 2 over 2 after you did that. Okay, so negative square root of 2 over 2. And you can check your answer on your calculator, obviously. Let me turn this on, sorry. Real quick, and then we'll do the challenging ones. So we're doing the cosine of 225 equals a negative 0.707, right? So I'm just going to go a negative square root of 2, divide that by 2, I get the exact same answer. Okay? So I'm feeling semi-good about that. So we're pretty good. Now, if they do this without a calculator, once again, you're going to draw a triangle. You're going to try to build a triangle based around one of those triangles that you guys know. Okay? All right, ready for the hard ones? The super hard ones? All right, let's do it. Super hard. Let's do the sine. $90 degrees. Evil.
That
There's two ways to think about it.
doesn't make it.
True. But it does make a triangle, and you're going to hate my triangle. But but it works. This is my way to dodge the stinking unit circle. Because I don't like that. She's excited.
Maybe embrace the unit circle.
Well, yeah. I know. Fine, be that way. All right, so if I try to graph 90 degrees, first off, if you were to think about graphing that, it'd go right to there, right? Isn't that the terminal side? Just straight up, right? So how do we build a triangle straight down right there? It's pretty impossible to do. We can't go this way. We always want to go perpendicular to the axis. So the only way to do this is to imagine that there's a triangle there.
Okay.
Like so.
And then connect it to the top.
And then we're connected, and then this line is basically going all the way to the top. Now the weird part about that is if this line was all the way to the top right there, how big would this little piece right here be?
Not 90.
No, this side length. Kind of a weird thing to think about. Think about it this way. Think about it this way. If this line were right here, right? Look at how big that is, right? As I get closer and closer to here, right? What's this one going to go to? How big is that going to get?
Small.
It's going to get really, really small. Like it's going to be 0. Like it's not going to be there.
Awesome.
Awesome. I know. This is why I need to show the unit circles. Think in unit circle. This side right here would be 0 because technically it's not there, right? It's slammed up all the way against that side right there. So that's right there is 0. Now these two sides right here, there's another weird concept. These two sides actually, if this is all the way over, these two sides are actually going to equal each other, which is funny. That means if I made like this 1, then this would be 1. If I made this 4, that'd be 4. They'd be the same. Okay, no matter what, as I slam that over there, those two would be the same. Okay, well now I can find the sine of this. The sine wouldn't be too bad, right? What would the sine equal is? What's the opposite and what's the hypotenuse? Opposite's 1, hypotenuse is 1. So this is going to be 1 over 1. It's not possible, but it's so close to possible that it's possible.
That makes sense.
So sine of 90 is 1? Ooh, let me check with my calculator. This voodoo is so good. Awesome. Now what about the cosine of 90? 0. Do that on our calculator, right? Cosine of 90? Hey, 0. Makes sense. 0 over 1. Okay, it's working. What about tangent? Domain error. How come it's a domain error? I'm dividing by 0. It's 1 divided by 0, right? 1 divided by 0. You can't divide by 0. So that's undefined. Okay, so that guy's going to be undefined. That's the way to do it without the unit circle. All right, you guys want the unit circle now?
No.
Some people think it's easier, so.
I don't know what that is, but
I don't either. No. All right, shall we do one more real quick? Let's do the sine of 180 degrees. And then, yes, I'll show you the unit circle. You can see it all its glory.
I was just going to say it quick.
Nope. Nope. Yeah, we got to graph this stupid triangle. It's not even there. So I'm going to 180, so that means I'm just going right on that line. So I'm going to get really close to that line like so. And I'm going to get so close to that line that which side is not going to be there? Which side's going to be 0? This far left side right here, that's going to be 0. And those two are going to be the same. So those are both going to be 1 just for ours. Okay? This is going to be 0 because this side is going to be right on top of that. So that's getting closer and closer to 0. So that one, for all of intents and purposes, is going to be 0. And now I can find the sine. What's that? Oh, you don't like it? Now I can find the sine, hopefully. Sine would be opposite over hypotenuse, which would be opposite is 0, hypotenuse is 1. So this would be 0 over 1, which is 0. Okay, so sine of 180 would have to be 0. You can find the other ones based on that exact same triangle. Okay, unit circle. Here we go. This is the unit circle. We'll be quick. Maybe. Unit circle is a circle with a radius of 1. So if I were to graph this, something like this, a unit circle means that the radius right here has to be 1 no matter what. It's got to be. That's not a unit circle. Anywhere on there, it's got to be 1. The problem is for all of our other ones, it makes our fractions super nasty, and so it's not quite as nice. Okay? But this right here is going to be whatever your x value is. This right here is going to be whatever your y value is. And that unit circle, we're always going to make 1 if we want to do the unit circle. Okay? Now, to do this, the shortcuts for this is the other way to do this triangle that doesn't exist idea. Okay? The way to think about this is, if I were to think of the sine function, let's say my theta is right here. If I do the sine of theta, right, what is the sine of theta going to equal? Opposite of hypotenuse.
Y over 1.
Y over 1, so just y. You guys okay with that? Okay, y over 1. Okay, now what about cosine? Cosine of theta equals x over 1, so just equals x. Okay, so cosine of theta equals x. And what about tangent of theta? Equals almost y over x. Okay, equals y over x. Okay, that's going to be the tangent of theta. Tangent of theta equals y over x. Okay, which means you can use this when you're actually solving for these other problems that we did over here. Like, for example, this right here, right? If this weren't right on 180, right? If this were right on 180, right here, right? What would the point be right here? What's my point value? If I was on a unit circle. Well, my radius out here is 1, right? So I would go -1, 0. Okay, I would go -1, 0. Now, we can cheat a little bit and look at this sine equals y, cosine equals x, tangent equals y over x, right? So the sine value equals whatever the y value is on that point. What's the y value there?
0.
0. Okay, so the sine of theta equals 0. So if we're on the unit circle, that's how you would have to do that. Okay, the cosine is the x value. So cosine, I should probably put 90 in there, or 180, sorry. Cosine of 180 is the x value, which is -1. So this would equal -1. And then the tangent of 180. Tangent of 180 would equal y over x, so it's going to be 0 over -1. 0 over -1, which is going to equal 0. Okay, so that's using the unit circle to find those. Like I said, I'm not a big fan of unit circles. I'd rather do triangles that don't exist, because that seems cooler to me. So, just my vote. So, anyways, let's go back and do that one sine 90 real quick with the unit circle idea, and then we're done. Okay, so let's do the sine of 90 degrees. Now, we already did the answer for this. If I were to graph 90 degrees, and we are on a unit circle, okay, if I were to graph 90 degrees, that's the point right there. Okay, now all I have to do is think about the ordered pair for that point. Okay, and what's my ordered pair for this point? If I'm on a unit circle, that's 1, right? So what's my x and y values here? How far left and right did I go? What's my x value? 0. Okay, 0, and how high did I go? 1 and a positive 1, so 0, 1. Okay, so now I can just cheat and use the x and y values and build my sine, cosine, tangent. I can do the sine of 90. Sine of 90 would equal the y value. The y value is 1, so this equals 1. The cosine of 90 is the x value. X value is 0. And then the last one, the tangent. The tangent of 90. This was that weird one that the calculator yelled at you for, right? Right? Tangent is y over x. Okay, so it's the y value over the x value. So it's 1 over 0. So it's 1 divided by 0. Once again, undefined for that one. So that one's going to be undefined. So if you want to use the unit circle, go for it. That's fine. If it lands on the axis, that's the ones you'll probably use the unit circle most for. If it's not on the unit circle, you're going to be building one of those special right triangles that we've done a lot. Okay? So you guys will be able to hopefully walk through those. Okay? Tough when they land right on the line. Forces you into that stinking unit circle. All right, we're good. 484. And 1 to 19 on.